Coming to you from the box room. Okay, so this is for Tuesday and Thursday, September the 15th and 17th. All right, so it's two classes, but it's really, we did one thing, because if we're doing an important activity like this, I want to go ahead and just make sure that everybody, at least in group 1 and group 2, get a chance to experience it. And then I filmed me doing a couple of them so the virtual kids would have that, at least that much of an experience. All right, so let's, I'll go ahead and start. I'll share the screen. Here we go. A couple of opening things here. For my ceiling panel, I'm trying not to rush physics. We are behind, but I'm not going to sit there and sweat it out. We're behind where we were last year, but you know, I'd rather you get it. Here's the key to 1.3, and this key is in two places. It's under the modules, under the where the assignment is. There's a key beneath it, and then also on the Facebook group, there's a key. So there'll always be a key a day or two after, probably a couple of days after it's been submitted, or it's technically should be done with it. We've not really submitted 1.3 yet. We will submit it. And yes, I do want you to go through and correct all your mistakes. I don't want you just copying it down, but at least correct your mistakes. We'll turn this in early October. Here's the next panel. Before we went out in the hallway, we first went out in the hallway. We did the metric march, and just kind of get a feel for what a meter is. It's like a big step. It's a yard, basically. So we walked the 30 meter march, and then we turned around, went from the origin, this is in the hallway, back to the 30 meter J roof mark, and we figured our pace. So we timed ourselves. Well, we came back in, and to write down our pace, which you know simply is the change, the change in position over the time it took you to get there. But a question came up early on, I think in first hour, or maybe the second hour, in group 1, they were saying, well, or maybe I brought it up, but the number I read off my phone was 25.42 seconds. But that is a measured number. And I am not that, I don't have that bit of reaction time anymore. So that's for me, it's plus or minus 0.2 seconds. We actually have this, quantified, and we're going to do the same. We'll do a lab later on, probably December or so, where we quantify your reaction times. So the thing is, I know my phone says 25.42, but when you look at it, let me see another one of these. This is one from one class, but let's see if I have it somewhere. All right, let's go back to this one then. When I look at it, it's really, because it's plus or minus 0.20, this could be anything from 25.22 up seconds up to 25.62 seconds. See, because it's plus or minus 0.20. So because I might have clicked the button too fast, I might have delayed my click. So you have to take into account that this number is real. It's not just out of a book. So the 25.42 is, I believe the 2 is right, the tens position is right. I believe the unit position is right. But my first iffy, the one if I'm reading this number left to right, the 2 is okay, the 5 is okay. But I'm not sure about the 4, right? Because that could be it could be a 2, it could be a 3, 4, 5, up to a 6. So that's my first iffy. So the rule is, when you're reading a measured number from left to right, and I have this written out down here, when you're reading a measured number from left to right, the first iffy is the last siggy. So if I'm reading 25.42 and I measured that on a stopwatch, then I believe the 2, I believe the 5, the 4 is iffy. That gives me 3 sig figs. So 3 significant figures. So when I write that, I don't write it as 25.42. I don't write it as this. I write it as 25.4 because I only, I've got to be, I'm trying not to lie. So I want to be as accurate as I can in my numbers. So when I divide those two numbers out, I went 30 meters in 25.4 seconds. I get, on my calculator, I get 1.1811 meters per second J roof. And we'll talk about the J roof, I roof in a second. So that, though, I cannot use these last numbers. I can't use this, those two, because that would be 1, 2, 3, 4, 5 digits in my answer. But you're only as accurate as your least accurate number, so I have to round that off to 1.18. So for this particular class, my pace was 1.18 meters per second. Now that's my general pace. I went ahead and put the J in. I put this J roof in there because I was doing it on the Y-axis. Let's look at another panel here. Here's another class, and that class I went a little faster. I'm trying to walk at a constant rate, but sometimes you're more tired, you've had coffee, whatever. So that's the point I was making, that this is fraud here if you write all those numbers out. I'm trying to keep you guys from doing that. You can only be as accurate as your least accurate number, and in this case, it was my time. So this rounds to 1.39 meters per second J roof. That was my velocity. Notice I put an arrow above the V, and really with vectors, you're supposed to put an arrow above them, but you get tired of doing that after a while. So when I think about it, I do it, but a lot of times I don't. There should be, if I'm going to be consistent here, there should be an arrow above the delta Y. Should be an arrow here. Should be an arrow. See what I mean? I mean, it gets out of hand after a while, and you just get tired of doing it. But sometimes it's nice in the answer to kind of formalize it there a little bit and say, okay, I'm talking about a velocity vector. It's obviously a vector because there's a J roof attached to it. And there's another thing of pace. Okay, let's go to the next panel. So I thought that I had some in here we were talking about, oh, here we go. Sorry. This is a little out of order, I see. All right, so that's fine. On unit vectors, let's talk about that before we get talking about the lab we did. But on unit vectors, I roof, there's I roof and there's J roof. And J, these are like cursive. It depends on what textbook you're looking at, but it's not capital J, it's a lowercase j. The J just, it looks like that, or it's just a J with the roof on it. Those are called unit vectors. Now the purpose of unit vectors is to make a scalar a vector. I think we talked about it in the last wrap-up session, Monday's wrap-up session. But it allows you to make a unit, allows you to make a scalar into a vector. Like if I say I'm going to walk 7 meters, but I don't say what direction, the reader needs to know which way you're going. So if I say I'm walking 7i meters or 7 meters I roof, that means that I'm walking east. Depending on how I set up my scale, if it's a standard scale, standard setup. If I say I'm walking negative 7i roof meters, then I'm walking west. If I say I'm walking if I'm going to walk 7J roof meters, or I could say 7 meters J roof, you can do it either order. You can do the unit, then the J roof, or the J roof, then the unit. But then it tells me I'm walking north. So you see what I mean? I mean, it allows, instead of just saying how far I went, it tells you what direction. And it's also used, any kind of scalar can turn into a vector with a unit vector attached to it. It's called a unit vector because it has a length of 1. We'll get into those more on Friday in class and probably more next week. We'll be hitting unit vectors all year, off and on. So when I was in college, my first professor called it I hat. They called him. And then the second time I took physics, the professor called it I caret. But I go with what Walter Lewin says. And Walter Lewin's from MIT. And he's I think he's one of the top 5 lecturers in physics of all time. That includes, I'm talking Michael Faraday, I mean, some of the best. Richard Feynman, I would say Walter Lewin's right up there with him. So he was the first in the 90s to put his course and this is MIT physics, on the internet, and allowed anybody for free to watch it. So I went through all 36 lectures back in the 90s, and then I did it again in the early 2000s because a lot of the stuff I talk about, I said, why not use the best, right? Why not use Walter Lewin? And so so one of the things I adopted from him is how he talks about unit vectors. He calls them roof. He's from like Eastern Europe. He calls them J roof. Now for the other direction, for the third dimension, the z-axis, those unit vectors are K roof. So it's IJK, right? So it's like XYZ, IJK. Why it's an I, J, and a K, I don't remember. I think one time I knew that, but I don't remember now. So out in the hallway, this is our setup. We start here in the west. This is where the west-southwest doors are for the science building. And I'm going to show you a video here in a second where it shows me walking through it. Start at the negative. I went up there a few nights ago, and I taped all these. I taped out the hallways so that they'll be there probably the rest of the year. They're sealed and all. And so we'll use them off and on. But negative 20 meters on the west side, all the way to Shader's room in that area, Miss Terry's room, that's about positive 20 meters. And then for the north-south hallway, that's our J roof, or our y-axis. And that goes from about the janitor's closet here, which is about -2, 2.5, 3 meters J roof, up to 30 meters J roof, okay, in the north side. One other thing before we leave this, this is K roof. So K roof, I've often wanted to increase the ability on this lab, because when you go into the janitor's closet, there's a ladder that goes up to the roof, and I wanted to include that, but the administration wasn't too happy with me letting you run around the janitor's closet. But when you go in there, you can walk up the ladder. That would put you into the K roof, into the Z-axis. And so someday before I finally do retire, I'm going to add a K roof to this. It has to be a straight up ladder though. It can't be stairs. The stairs will be a combination of I roof and K roof. We'll get to that, but that's a little harder. Okay, so this is the way you show right here. This is how you show a vector coming out of the page. It's coming right at you. If I roof, I roofs, these are all vectors are arrows. So K coming at you is and then if it's going into the page, then the vector looks like this. It's an X. Okay, so I'm going to pause this, and then I'm going to call up a video and share another screen. So first, let me pause it, and then pause recording. Okay. All right, so I'm going to try and share this iMovie with you. Let's hope it works. Now, and this is the east-west hallway. So every meter, that's -18, -17, -16, every meter is taped off, okay? So the idea of 1.4 is to get you into the graph, into the grid system. Here's our origin. So this is where the I roof meets the J roof, and J roof is the y-axis. So we have negative I roof, positive I roof, that goes down to Shaders and Powell's and Miss Terry's room, and then all the way up there to Miss Cook's room, Mr. Cox's room, that is the y, positive y-axis. There's a little bit of negative axis. And when you're looking at your sheet 1.4, it might say something like, it gives you an equation, right? And then you got to go from there. Well, it's the equation is, hold on. The equations we were using are, this. So that's the red equation, but the X naught is where we start, and then the V is how fast we're going, okay? And that's it. So that's all we got to know is where do we start, how fast do we go, how long do we go? That's a T. That'll be important. Okay. So let's say that the equation is 2 meters is x is the y of t, because I'm on the I-axis, the j-axis, the j-roof axis, which is the y-axis. So let's say that the equation is y of t equals 2 meters per second times t plus 8. So this is my initial position is 8. So and it says you got to do that for 5 seconds. So if I'm going to go 2 meters a second for 5 seconds, that's 10 meters. Well, I'll end up at the 18 meter mark, and I've got to go at double speed. We're going to fast walk. Ready, go. 18. Okay, so I got there, and I probably went too fast because that's I was supposed to have 5 seconds. Well, let's try another one. Let's go down here. Suppose we're going to start, that was a J roof one. Let's do an I roof one. Now suppose we start at, let's start at 4 meters I roof, 4 meter mark. So right by the boys' bathroom here. And let's say we're going to go a half a meter a second, and we're going to do that for, let's say 20 seconds. Half a meter a second for 20 seconds, and we're going to start at 4. Okay, so half a meter a second, 20 seconds is 10 meters. So I should end up at the -6 meter mark, right, in 20 seconds. Ready, go. Half a meter a second. Okay, and I got to end up at the -6. Okay, now I'm crossing the origin. -1, -2, -3, -4, -5, and my final position is, oops, -6. So there's also ones where you have to look at a graph, but the switch this around. But the graph ones are okay. So the graph ones are easier to walk because you're given on a graph, on a linear graph, you're given your initial position, you're given your final position, you see how much time it takes. The only thing you got to do is write an equation. So that's a little harder. I mean, you got to figure out the slope. That's your velocity. So each person had to do a graph in the Y or the J roof and a graph and interpret a graph in the X or the I roof. So look at 1.4 and you can set something up like this in your backyard if you want, or your driveway, or your sidewalk, whatever. And just to get yourself into it a little bit, so you start to get a feel for, that was the whole idea, just to get a feel for this. Okay. All right, so let's pause that again. Okay, so that's sort of what we did. That's what we did on Tuesday and Thursday in class. Is we went out and we're trying to do this. Let's go back now. So we're trying to do this this sheet here, 1.4. Now I have we went over a couple of them in class. We did trial B and trial R. Now, if you're virtual, you can pick any of these groups and just try, kind of work your way through 6 of them. So you have all what you're supposed to do down here. There's your trials. And then there are trials at the bottom, and those are graphs. The graphs actually are kind of easy as far as doing it, because it tells you where to start, it tells you where to end, it tells you how long to go. You don't see your speed, but for those graphs, you have to go back and write the equation. It's the only hard part. So here's one where we did it, this for trial B, where we started, and I found that out because, look, B starts at 4 meters. Okay, B starts at 4 meters right here. It tells me initial position. And then how did I get this 10 meters, right? 10 meters I roof. Well, 10 meters I roof comes from, I know I did it for half meter a second for 12 seconds. 12 times a half is 6. 6 plus 4 is 10. So I ended up at the 10 meter I roof position. The distance I traveled in was 4 to 6 or 6 meters. But displacement is more, it's a more detailed version of the distance. Distance just tells you how far you went. But displacement tells you three things. It tells you what axis you were on. There's the I roof. It tells you what direction you were going, whether it's positive or negative, and it tells you how far you went. So displacement tells you three things, whereas distance only tells you one thing. So displacement's a vector, distance is a scalar. Because with distance, the direction doesn't matter. R, we got R from the graph, this graph over here, and that's a little blurry, but looking at R is on these graphs, it's in the Y. This graph is Y versus T. This graph is X versus T. Okay. So the Y is your J roof axis. So when I go here looking at R starts here at 0. Looks like, I think I'm seeing it right. You have your paper in front of you. And then it goes out to, looks like 12, and it does it in, appears to be 18 seconds. So over here with R, I started at 6, I ended up at 12, and that's just the graph telling me that. And so therefore my distance I traveled was 6 meters, and because I'm in the J roof, I write this as delta Y, which is the symbol used for displacement. Delta Y is equal to 6 meters J roof. Now the hard part on these, the graph ones, oh, by the way, you're supposed to graph up here, you're supposed to graph, once you figure this out, you're supposed to graph the equation for all the ones where you're given an equation, you got to write a graph. All the ones where you're given the graph, you got to write the equation. So here, that 0.33 I had to get from the graph. I think it was 6 over 18, right? 6 meters over 18 seconds. So 6 divided by 18 is 1/3. I'm not supposed to show fractions. So that's 0.33, because I got to say, and probably 0.33 is being optimistic, but I'm going to go ahead and give it 2 sig figs. So 0.33 meters per second, J roof T, plus then my initial position was 6 meters. So that's what, this is all is what is due on Sunday, is to have all this done. Now, you can go to Facebook, because on Facebook, I have 1.4, and I've already put some help. There's some, I have a key, part of the key there. So take a look, and I'm hoping that'll generate some questions. I'll eventually post the whole key, but by then you will have already submitted it. Okay. So let me see if there's anything I'm missing here. Oh, let's go back to here for a second. There's the thing with distance is a scalar, displacement's a vector, what we were talking about a minute ago. Displacement is just much more descriptive. And then all we got left here is the to-do list. The to-do list is for, you're going to do this optional Zoom, which starts tonight in about an hour. And then you're going to submit any late work. You're losing 5% a day, and that is, you lose up to, let's say, up to 30% off. So you still could get a 70%, even on like something as old as 1.2. So like sheet 1.2 was due, I don't know, what was the last week, and it was worth 20 points. Well, if you didn't do it at all, there's still some of you that haven't done it, you can still get 70%. And what is that? What's 0.7 times that? So you still get 14 points, up to 14 points is still available. So 14 out of 20 is much better than a 0 out of 20. So go ahead, and if you haven't done it, the key is posted on that. I don't want you to just copy off the key, but you have to do what you have to do to get that thing submitted. So 14 points you can still get, and that's good. You can always do that. You can always turn it in. I think up to the end of the semester, I give everybody a chance. You know, if they want to turn it in for 70%, that just seems fair to me. If you had a rough September or something. Okay, and then what else we got to do? That's 1.4. That's by Sunday, 11:59, and I don't plan on giving any extensions on that. So we got to get moving here. We're so far behind. Then also join that Facebook group if you want help on 1.4. Now you're probably going to want help on 1.5, which is tomorrow. So I would strongly suggest you not only join the Facebook group, but you actually go to the Facebook group. So Canvas will be sort of what we'll do. Canvas will be our scaffolding for, you know, assignments and things like that, and screenshots and all that. But Facebook will be sort of our night physics, how we learn physics outside of class. So virtual kids will really do a lot of that. Okay, I think that's it. Thanks for listening. How do I turn it off? Oh yeah, end meeting. Got it.